Hello new friends! Welcome to my channel, where we will learn what is and what means the Riemann hypothesis, the greatest unsolved problem in mathematics. In 1859, the great German mathematician Werner Riemann, our protagonist, presented to the Academy of Sciences in Berlin a paper entitled "On the number of prime numbers below a given quantity." This work, included in a manuscript of only 4 pages, had a fascinating depth and originality and has led to one of the most attractive mathematical problems throughout history: the Riemann hypothesis. Werner Riemann, in his work, conjectured a hypothesis that generated the greatest mathematical movement to prove it. What is the Riemann hypothesis? It's a mathematical conjecture intimately related to prime numbers. If the hypothesis were true, we should look at the prime numbers in a certain way. But if it were false, we should look at them in a totally different way. Today, in January of 2018, it is not known. The hypothesis is recognized as the main existing mathematical problem, so much so that the Clay Mathematics Institute, a private club of millionaire fans of mathematics, has instituted a prize of $1 million for anyone who manages to unveil the mystery. What does the Riemann hypothesis say? The Riemann hypothesis says all non-trivial zeros of the Riemann zeta function have real part 1/2. Well, said in this way, we surely do not understand anything. This short sentence is a phrase devoid of meaning, and if you look closely, in such a statement do not appear the prime numbers anywhere. But I assure you, this concise phrase has a deep mathematical meaning, and the prime numbers are there, at least hidden. If you are brave, we will discover it. Is not it worthwhile to understand what today is considered the greatest mathematical problem? Riemann's works connected in an elegant and brilliant way the theory of prime numbers with mathematical analysis, opening multiple paths to later researchers who, in turn, have led to surprising results. These videos will help us understand the work of Riemann, to formulate his hypothesis and learn of all its implications. It is amazing that the prime numbers 2, 3, 5, 7, 11, 13, 17 and so on, something that is so simple to express, so primary in the wide world of mathematics, has led to such profound studies, to so much literature, to so many theorems which are among the most complicated and yet subtle. Something as clear as prime numbers, which are but natural numbers with a particular property which makes them unique, has troubled the minds of the greatest geniuses of history, not having reached to this day to fully understand their nature. Which mathematicians have contributed to the knowledge of prime numbers for history? Euclid, Euler, Gauss, Dirichlet, Riemann, of course, Hadamard, Landau, Hardy, Littlewood, Siegel, Selberg, Odlisco, Conry, and many others that will arise throughout the chapters. They are the real pillars on which all other mathematicians have supported their work. They have made us see the light, but not all the light, between the shadows that exist in this infinite set of numbers that we call primes. Let's say right now, no mathematician who has contributed to the advance in the knowledge of prime numbers, none, is entirely satisfied with their contributions. All, without exception, have experienced at the end of their work the slightly bitter feeling of not having reached the end, of having fallen by the wayside. Because, in the end, we always find the Riemann hypothesis. But what do mathematicians think about the hypothesis? Well, quite a few mathematicians believe that the Riemann hypothesis is true. A few others believe that it is false. And there is a third group that simply does not comment. They believe that it can be true or false. There are passionate mathematicians and there are skeptical ones. And there have been great mathematicians who have tried to prove the Riemann hypothesis or refute it, but unsuccessfully. Really, the question is that the hypothesis could be false. We don't know reasons for which it should be true, beyond an aesthetic or romantic sense. Is this a complicated content? Not if the viewer does not want to. This set of videos is not for professional mathematicians, but for math students or amateurs. Prime numbers are inherent to us, so in principle, understanding them should not pose any problem. Prime numbers themselves are mysterious and attractive, but the history of mathematics that we know from Euclid in the 3rd century before Christ until today is also attractive. Throughout the chapters, we will discover the mathematical atmosphere of large universities and historical and current research centers, where the plethora of men and women captivated by the primes worked. We will move through countries and continents. Greece initially, Europe until mid-20th century, and America to this day. We will discover his work as it was interpreted at the time, the schools they created, and the disciples they had. Therefore, these videos are not purely mathematical, they are also historical. What we will learn in this collection of videos? We have to follow a mathematical and historical path that leads us to the Riemann hypothesis. First, I will present you what the prime numbers are, their properties and basic theorems, already settled by Euclid. Then we will meet the genius Leonhard Euler, his life and work, and his key contributions to prime numbers around the year 1750. Later, we will introduce ourselves into the infinite series, arriving at one of the most surprising results of the theory of prime numbers, the Euler product, necessary to understand the Riemann hypothesis. Next, we will meet, perhaps, the greatest mathematician in history, Carl Friedrich Gauss, and we will know his long and patient work on prime numbers, leading to the famous prime number theorem around the year 1800. Later, we will go into the first third of the 19th century, knowing the work of mathematicians such as Chebyshev and Dirichlet. Then we will introduce the functions of complex variables, and we will know the so-called Riemann zeta function, the nucleus of the hypothesis. Later, we will know the life and work of Bernard Riemann between the years 1826 and 1866. Next, we will see in detail the Riemann zeta function and its analytical extension, a very intelligent mathematical tool. Then we will know what the trivial and non-trivial zeros of the Riemann zeta function are, and we will approach the Riemann hypothesis. Later, we will know the advances on the prime numbers and on the hypothesis during the years 1860 to 1900, with the work of mathematicians Mertens, Stieltjes, Bowman-Gold, Hadamard, and de la Vallée-Poussin. Next, we will make a small historical stop, and we will focus on what the Riemann hypothesis means. Later, we will know how the Riemann theory makes us see the light on the pattern that the prime numbers follow, and how the prime number theorem conjectured by Gauss was proved. We will enter the 20th century with the help of mathematicians Hardy and Littlewood, who, from Cambridge, made the hypothesis fashionable in the mathematical world. Later, around the year 1930, we will learn how the mathematician Siegel rediscovered and published Riemann papers and what that meant. And to finish, we will see all the important advances from the year 1940 until today. The Riemann hypothesis and its unexpected and mysterious connection with quantum mechanics and with the theory of operators and matrices. A final chapter will allow us to know the opinions of two great current mathematicians who have worked with the Riemann zeta function and who have contributed with important results. Andrew Odlyzko and Brian Conry, whom I had the pleasure of interviewing in Minnesota and California. We will know, by means of their authorized voices, what they think about the hypothesis. Therefore, moments of great mathematical interest await us. But don't panic. I will take your hand and guide you through a comfortable walk, through a harmonious, tranquil, peaceful, sunny journey, peering at fantastic landscapes of mathematical knowledge and figures. A very long journey which began many centuries ago and that still has a long way to go. It is worth taking a look. See you in the next chapter.